Alright, so this section is about rhombi and squares. So the goal is to recognize and apply the properties of rhombi and squares and determine whether quadrilaterals are rhombi or squares. So the vocabulary for today is rhombus and square. So properties of rhombi and squares. So rhombus is a parallelogram with all four sides congruent. All of the properties of a parallelogram hold true for a rhombus, in addition to the following two theorems. So diagonals of a rhombus, theorem 7.15. If a parallelogram is a rhombus, then its diagonals are perpendicular. And theorem 7.16, if a parallelogram is a rhombus, then each diagonal bisects a pair of opposite angles. So let's look at this. Square, so a square is a parallelogram with all four sides and all four angles congruent. All of the properties of parallelograms, rectangles, and rhombi apply to squares. For example, the diagonals of the square bisect each other, parallelogram are congruent, rectangle, and are perpendicular a rhombus. So example 1, use the definition of a rhombus. So if L to M equals 2x minus 9 and K to N equals x plus 15, in rhombus KLM, find the value of x. So L to M is equal to K to N. So that's what we're going to plug in over here. And same thing, just definition of congruence tells me that they're equal to each other. So now I can use the expressions. So LM is 2x minus 9. Kn is that x plus 15. So now I'm going to go through and solve. I'm going to write this over here so I have more room. So I have 2x minus 9 equals x plus 15. So I'm going to get rid of this 9 first. So now I have 2x. Those 9's cancel. So now I have x. 15 plus 9 equals 24. I'm going to get rid of the x on this side, so I'm going to subtract my x. So now I have x equals 24. So now, example 2, use the diagonals of a rhombus. So the diagonals of a rhombus, KLMN, intersect at P. So if LMN equals 75, find KNP. So because we know that KLMN is a rhombus, we can use the definition of a rhombus to say that LKN and LMN are congruent opposite angles. So this angle and this angle equal each other, and they're bisected by K to M. So that one cuts it in half. So because KM is a bisector, PKN is half of what LKN equals. So the angle of PKN is 1/2 75, which equals 37.5. So because the diagonals of a rhombus are perpendicular, the angle KPN equals 90 degrees. So those three angles added up together equal 180 degrees, which is just the triangle angle sum theorem. So 37.5 plus 90. So we're going to do this over here. Well, actually, we can just do it like this. So 37.5 plus 90 equals 127. So now I have, and we'll treat this as x. 127.5 plus x equals 180. So I'm going to take 180 and subtract that 127.5, and it gives me 52.5. We use the definition of a square, so EFGH is a square. If F to J equals 19, find F to H. So we know that F to J and J to H equal each other. So that would go here. So substitution, so we know that JH, or actually we know that FJ equals 19. So because both of those equal each other, fj plus jh, so we would have 19 plus 19. We're just going to do that one down here. So 19 plus 19 gives me 38. So here's some tests for rhombi and squares. So if a parallelogram meets certain conditions, you can conclude that it is a rhombus or a square. So theorem 7.17 says if the diagonals of a parallelogram are perpendicular, then the parallelogram is a rhombus. Theorem 7.18 says if one diagonal of a parallelogram bisects a pair of opposite angles, then the parallelogram is a rhombus. Theorem 7.19 says if two consecutive sides of a parallelogram are congruent, then the parallelogram is a rhombus. And theorem 7.20 says if a quadrilateral is both a rectangle and a rhombus, then it is a square. All right, go ahead now and make your lesson to teach the class.